So, students, this is another problem in which we will be using the principles of moments to determine the reactions or the forces as given in the problem. Here I have a rod which is in the shape of a T, and it is held at point B using a spring whose spring constant is given and is hinged at O. If I have to make the contact at C cease from the wall, what should be the force P? This is the question, and the dimensions are given. So we will start this solving this problem by constructing the free body diagram. Let us say this is O, this is A, and this is C. At B, there is a spring force Kx which is acting, which is pulling it back. There is a force P which makes it go in the clockwise direction, counterclockwise direction. Let us say it is pinned here. It's pinned here, so you will have a Y. It's free to rotate about O, about this point O. So the weight of the rod acts at this point along this O. I'll call this point as D, DC, which is going to be 0.05. This is 60 mm. There's another 60 mm. This height is 40, and there is another 40. For equilibrium condition, the net forces and the net moments has to be 0. And at the verge when it breaks contact, the moments due to, as it is fixed at O, if I take moments about O, the moments due to the force P and the weight should be equal to the moment due to the spring force. So using this criteria, we will solve this problem about O. P into 120 into 10 to the power minus 3 plus 0.05 into 10 into 60 into 10 to the power minus 3 should be, both are in the counterclockwise sense, should be equal to the spring constant given as 1750 into the stretch is 10 into 10 to the power minus 3 is the spring force, and its moment is 40 into 10 to the power minus 3. Solving this, you get P to be equal to 5.58 Newton. This is for case A. For case B, neglecting the weight, you should the problem becomes much more simpler. It is just into 10 to the power minus 3 should be equal to 1, based on which we get P to be equal to 5.8. Thank you.